Hello and welcome back to compiler programming. With the variables out of the way, I think today I'm gonna try to make hello world program work. So we already have it in multiple variations. I just need to find one that we can use. This I guess will be okay. So this is the one that using macro, and we are essentially going to be just doing exactly the same thing as we are doing here with the parsed code. So I'm just gonna copy it to, I guess, somewhere around here. Let's paste that in and parse and write an executable that means hello world. That seems fine. I will comment this out, but keep it as a reference, and instead I will take out this source code. Okay. Test parsed hello or something. And let's look at our functions that we need. So we need exit process, and then we need to have get std handle. So let's do that. We also need to have write file, and we'll need this constant. Constant for now, I'll just hard code, and write file is going to be the trickiest one because, as you can see, it requires pointers, including void pointers, and right now we don't know how to parse those at all. So let's try to figure that out. First of all, I'll just put this in and say write file. I'm just gonna copy this stuff, and then I will change it to how I want it to behave. And this is where we need to think how to deal with this stuff. So this next argument, I think, is the buffer. Then we have size, and this is bytes written, which I think actually is an S32 star. And finally we have overlapped, which is for overlapped AO, which is not something that we need to think about right now. Let me rearrange this stuff just a little bit so it is easier to read. I think something like that would be fine. But first thing first is we need to figure out pointers. Right now, argument parsing code will not handle this, and additionally, I'm not exactly certain I want to keep this syntax from C. I have an idea in my head about a different syntax for pointers, which is not just because I want to have different syntax, but because it I think makes more sense. But with that syntax, something like this becomes weird, because void is nothing. Like, I think in general in C it's quite unfortunate that you have void pointers. It's because void means nothing, but then pointer to void is like pointer to nothing. So it's kind of strange. So it means actually it's more like any and then pointer, or unknown and then pointer, so something like that. So I don't really like the void there. This is the first thing I want to change, but I'm not exactly sure what to do here. And the second is about what to do with a star. And what I don't like here in C is that you have two operations that have exactly, well, in 99.9% cases, they have exactly the same semantics, which is like you can do star, right? So you can do like this to go from pointer to a value, but you can also do this, and they are the same thing. And also, as far as array goes, when you just pass pointers and you don't have the size of the array, so it's like it's weird. Now, different languages went different way, but the most common one is to have something like this, which is an array that implicitly passes the length and the pointer. But this is also limiting because if you deal with APIs, and unfortunately there are a lot of them, or fortunately, I don't know, like legacy C APIs, they expect null terminated things, and I don't know, Windows APIs expect null terminated things, not necessarily even strings, just like you pass in an array of something and the last one is 0. We saw that in P32 encoding, for example. So you end up having these custom types. You either constantly convert things, or you have like a gazillion of different types. So I think Rust went in that direction, and Zig also has like null terminated, non-null terminated, sized, unsized slices, and so on and so forth. So I think that's just would be nice if there was a better way to handle this inconsistency. And the idea they have is to use a more like variadic tuple syntax from something like TypeScript, where these square braces would just mean this is a region of memory, and inside of that region of memory you can put different things. So this would mean this is kind of a pointer to unknown thing, or like pointer to any, maybe, is roughly the same size as void star, so people won't complain that typing too much. So I think this is kind of good. And particular long term, I even want to do it something like that, where you say you don't even know, like you have no idea about the size, you don't know, it's just some stuff. And in cases of sized arrays, you would have something like I don't know, S32, or maybe even named, where you say size is 32, and then you have here S8 of size, something like that, right? So you explicitly tell that this is the array of this size, and then we go into dependent typing and so on, but that's all not important right now, and I don't know if it is going to work, but I just thought I would explain why I don't want to use standard C syntax for pointer types. So I think this is what I will go for, and right now internally any will just literally point to void for the purposes of parsing. That's not great, but eventually I will probably introduce any type. But for now, that's okay. And here it is going to be S32 like this. So this is probably what I will use for defining this stuff. And now we need to figure out how we're gonna call it. So I'm gonna split this up into multiple lines, so it is easier to perceive this stuff. Have exit process. It's gonna be now exit process of 0, because we actually have real stuff to do in the program, and we're not gonna use exit code to verify that everything worked. Now the next thing is actually going to be around strings, which also don't really exist right now we can't parse them. So that's something to consider as well. Maybe I will even like comment out this test and first write tests that do smaller things. So for example, I don't know, a test that just returns us a string, right? But I want to go through all of it and have a kind of a list of what we need to have to make that happen. Okay, what happens here? Well, we have these bytes written that actually can be null pointers, so we can ignore that part. Then we have message bytes, and we have message pointer. Okay, this is part of dealing with the string. Okay, and also, by the way, in P32 writing, we don't right now have a constant thing, so technically all of our stuff here will be mutable, which is not amazing, but it's fine, at least for now. And we write this stuff. Okay, so let's start. We have handle, which is gonna be get std handle, actually like this, get std handle of -11. I can actually probably even do nicer and say std output handle is I can probably do it even this way. Let's see if that works. But it would be ideal. So to define a constant value, it also will not use stack space. So we have a handle. We have a kind of a descriptive handle. We get the actual handle that we will pass to write file, and then we are ready to call write file. So this is what we're gonna do. We're gonna say write file of handle. Then we'll need to have that message, and this is going to be interesting. Like I will need to make a decision what is the string type. Considering this stuff, I think that strings should have a very weird type, but right now I will probably choose it. And so we have, I don't know, something like this. I'm not sure what's gonna happen here, to be honest. But this is the idea that we have message, we have length of message, and next one is bytes written. So as I said, we can pass a null pointer to here. I hope we can convert 0 to null. Honestly, I'm not sure, but that's something we also can fix. And finally, this is also a 0. Like worst case, if we can't convert 0 to null pointer, I will just turn this to S64 and call it day. The bigger thing is the buffer that we need to pass in. We also can... So I think I will do maximum choosing right now, and we will say that... no, not important. Okay, let's keep it right now like this. Do I need to do anything else? Doesn't look like it. So I'll say parsed hello world. Okay. We also don't have message, so let's do that. We say message is, and I will need to escape the quotes. Hello world. Right. Okay. So as I said, there is a bunch of stuff here that is not going to work, so I'm not even going to try to run this. It's going to crash and burn quite horribly. So instead, what I will do is I would say should parse and how do I want to do this? Parse and return C compatible strings. So let's do that. Okay, I don't actually want to write executable. Maybe I want to do this stuff where we do program end. Yeah, let's make this version. Checker, checker, checker. And here I will need to figure out what is the type of this. And the type will be what? Well, let's say it will be string, whatever that is. So we'll define it and then actually no. Let's go all in. I don't know how long this video is going to take, but I want to make that happen. So the type here will be S8 and then 0, because that like if you have programmed in TypeScript or something similar, you know that means that like there can be any amount of S8s followed by 0. Right? This is the nice type. And to avoid parsing it, I can again do this. So yeah, let's start with this version, and I will just programmatically create this type, because right now I don't think we can even represent it with current descriptor stuff. So there's going to be a lot of changes there. But here I will say that I'm returning test. Okay. And the type will be now void to const char p. Okay. And this is going to be const char star string and check str cmp string and string test is 0. Okay, I will need value.h for definition of this. So void to, so this returns const char star. And this is void to const char p. Okay, it looks like it's built. I can try to run it, but obviously it will be very unhappy with that. Okay, I think the first thing it fails here is that C-string definition, so I need to actually define that type, and I would say C string, and here type C string value. Let's go to where these are defined and try to figure out what is gonna be the type of this. The easiest option right now, just to make the test pass, would be to make the type of that just a pointer to char star, same as in C. And I guess that's not a terrible option, again, at least to make the test pass, and then we'll figure out that complex type with zero termination later. Okay, type, this is going to be type C string, and descriptor is going to be something different. Descriptor is going to be type descriptor type pointer, and pointer is like this. Left of type must have right. I need to do like this. Pointer is not a member. Descriptor is like pointer too. Okay, so we have a descriptor, at least parsing of the arguments should now work, and we are exploding in line 604, so let's check that. 604. Okay, cool. So it has no idea what to do with a literal string, which is fine. Can take care of that. So we have token type string. I think I have somewhere token string to slice. That looks good. Let's bring it up a bit. And here we can say slice content, or slice string is token string to slice of token. Like all it does, it basically cuts out the opening and closing quote. Actually, here we should do assert token type is token type string. Okay, that looks good. We have a string, and now we need to do something about that. And what we need to do here is I think we might have this somewhere. So global string or string global. No, we don't have anything like that. What do we do in the original one? This one, value global C string. Okay, so maybe I can do that. Where are you defined? You're defined here. So I think I will need to also have it over here. Missing. It has no idea what value is, I think. Yeah. It gets a C string, and would be nice if instead it would get a slice. And yeah, I think would be nice if it got a slice instead, or we create a version like this from slice. So we will get slice, and here we'll just copy this stuff and see what we need to change. So length is very easy. We now do slice.length plus 1. We allocate fixed size array. That's good. We get this pointer, and we copy this stuff. I guess that's fine. What happens? So except for yeah, so here we need to say S8 star memory is like this, and memory length is -1 is 0. Something like that. I could probably merge these, but it's okay if I don't at the moment. I can add the to-do saying refactor common parts with the one below. Okay, so we have this stuff, and we can actually use it here, where we can say value star value is this. We do builder program, and then we just pass in this string. Okay. And now, yeah, this is just going to be a result value. So if everything works, this is exactly what's going to happen. String undeclared identifier. Slice dot bytes slice dot length. Yep. Well, let's see what's gonna happen. Did not find an acceptable encoding. Why are you trying to do this in the first place? That's kind of interesting. So we are trying to do this, like I can see here where we are trying to make that happen. So obviously it's move value, it is line 75. So we ended up in here, and I do know what is going on. It should have been caught at a different point in time, but I believe I need to do this. Yeah. So this value is kind of not really a pointer. It is a location in memory, but we need to point to that if you want to be a proper C array. So I will say value pointer to like this. And that should work. And then I can figure out later why did it pass. And I think the reason it passed is because, yeah. So the size actually ended up being exactly correct, and that was a bit of an issue. So if I undo this, just to verify that I understood exactly what happened, because I think it is really important to know. So if I would change here to be like this, so we have a larger array, its size would be larger, and I would actually catch it in move value. Yeah. So we have we did catch it earlier. Okay, so I understand exactly what's going on. This is unfortunate, but this is not what I'm working on right now. So let's get back to the version that should work, and we will continue from there. Okay, so this is great. We now have a way to create C strings. As I said, long term, I don't want to for it to be this way, but it should. But whatever is the type of string that we will end up with, it will eventually be implicitly castable to C strings. So this type will still stay. The only thing that will change is the type of this, but then it will be castable to this thing in some shape or form. And there are different options. I could also maybe not have a type for it at all, like have a immediate string thing, and that is or compile time string, and then do something about that, but we'll see. Okay, so this works. That means that we are ready for this. Although the next thing I can do is actually to not define this type here, and instead do this. And I think that's a nice idea as the next thing to do, because I can do it like this, and I can actually get rid of that value type. It's not here, it's here. Yeah, I think that would be even nicer if this would be gone. But now if I try to do this, it will be like, what? I expect an identifier there. What did you give me? So let's fix that. And that happens in token match argument. And here, for now, again, just to make progress, I will match anything, and then I will say that so it wants to return a type name, and that's not what I want. What I want here to return a descriptor. So let's start actually with that. I will keep it as this and say descriptor star type and descriptor, and we will take this thing from here and make it there. So we say arc descriptor, or do they call it type descriptor? Yeah, I called it type descriptor. So let's do type descriptor is this stuff. Arc type source. So all of these tests still should pass if I haven't messed up anything. Okay, so we are ended up with the same error. Great. Now we can start doing better job at it. You can say descriptor star descriptor. It can be just descriptor is 0. Then we do switch of archetype type, and we do case token type ID. In this case we know exactly what to do. So this descriptor is this. If it is a token type square, then I want to, for now, assert that archetype children dynamic array length of children is exactly 1. And then we have one child, we can get it. We can say token star child is dynamic array get of archetype children 0. We assert that child type is token type ID. Again, obviously, fix me should be recursive, so it should be have a pointer to the pointer to the pointer and so on. But as I said, like this whole thing will eventually change, so that's not a concern for now. For now, I'm trying to make this work. Okay, we get an ID and we say that this descriptor is temp allocate of descriptor star descriptor is type is descriptor type pointer, and pointer 2 is program lookup type. Okay, that seems fine. And in other cases, we assert and say not implemented. Templegate, this needs to be like this. Okay. Token star differs in level of interaction. That's okay. This one is now complaining that we don't handle all the token types. Do I want to? Well, I guess I can. Where are all the token types? Just in case. Okay. Case. And case. We have square here. And the rest should be like this. And then we can even remove, I can keep default, that's fine. Are you happy now? Good. This warning can be annoying on occasions, but in general, it's very, very good warning to have, that you know that you switched over all of them. I would prefer it if it was possible to control it per switch, and maybe it is, I just don't know, but that is fine for now. Let's see what happens when I try to run this now. Okay, assertion failed, return type, token type is token type ID. Where does that happen? So, oh, that's actually quite interesting. Well, the first thing is here, we need to remove this. Actually, I think I need to do this. But what happens actually is that we need to have something like token match type, or yeah, let's call it token force type. It would get these, it would get a program, so it would get like token star, oh, maybe first program, and token star token, and then we would get this thing. Actually, it should return a descriptor, not a value. Okay, we return a descriptor, and now we can then say token force type, program type. Okay, and the same thing can happen in here, where we are dealing with return types. Yep. Return types. Yeah, so it was doing program lookup type. Now it will do this version. Return type token. Okay, let's see if that helps. I messed something up here. That's pretty easy to fix. And here I'm missing an underscore. Okay, let's try that again. Yeah, we don't need this assertion anymore. It's going to be part of this token force type. Okay. What were you not able to find? I thought I used S8 there. Where are you? Yeah, this should be S8. So that's kind of interesting. Oh, yeah, that's because I did the wrong thing. Let's try that again. And it works. Great. So I think that's good enough for this purpose. We have this type, we can parse it, and that means that we should be able to deal with this stuff. And I think I will, in the interest of time, I will do it this way, and I said I might have to replace this with S64. In fact, I will just do it for now to make progress. So if everything is great, this should just work, but things rarely do. So let's see. Something is not implemented. What is not implemented? Line 660. 660. Okay. Let's do printf. We need a nice way to look up the type. So whatever, I will just open Visual Studio and see what's going on there. So looks good. Which file are we? Yeah, I need to change this stuff. Functions spec. And let's run that. Okay, so we have an assertion. And what is the type that you are unhappy with? It is an operator. Oh, yeah, that is that is an interesting one. How do I want to deal with that? Minus is a very problematic operator because it can be binary and unary. So it can be like x minus y, and it can be just minus y. And which one you need to choose depends on the context that you have. So I think I will choose it for now and say that we have, where is this stuff? For example, I'll take these and I will say that token right to a negative literal. So this will break long term, but short term I think I can do this. So if we have, in fact, I think I can so what are the rules for the unary stuff? It needs to be on the left hand side, it needs to be something that is cannot be an argument to the binary one, right? So if you have stuff like this -1, that's obviously an like just a -1. You can have 1 plus -1, and then on the left side you will have an operator. So I guess this is what I will do. I will look for an operator. Like I don't have a not match right now, so I will do it manually. I will match like something. Then we have minus, and then we have again. Well, actually, here I will just do integer for now, and I will say that if so it also needs to match nothing. And right now I don't have a good way to do alternatives. So let's not do this. Let's just do this version. And it's fine if we do the wrong thing long term. I can do fix me distinguish unary and binary minus. Okay, we have this. What do we need to do? Well, pretty straightforward. We need to force a value. So we say value star star result is token force value. I think it accepts a integer scope and builder, probably. Let's see if I did it correctly. And then I say result operand this is quite unfortunate, but I will need to do this. Switch on results operand type and case this is going to be annoying. I'll do it with if so basically, depending on the size of immediate, we need to use a different field inside of the result, and that means I need to do this switch here. If result type is operand type immediate 8 result operand immediate 8 is minus immediate 8, else now I can just copy paste this stuff 2 times. At some point it will be more times, and here I will do 64 and 64, 32, 32, else assert internal error expected and immediate. Okay, something like that. We replace 2. I already forgot what is the way to do this. Okay, result token. I will need to create that result token, right? Token value make, yeah. Token value make. Rx token, no, this is gonna be integer and result. Okay, this fix me does not have to do with this. This is also fine. Okay, let's see how that does. Yeah, I forgot to actually call this, so it would really help if we did something with it. I think I will even do this as the first pass. Okay, we are making progress, which is good. So we failed to get something. Let's see what we failed to get. Scope lookup force. Yeah. This is another thing that I will not do at the moment, so no links for me. I will tell you myself. So 4, 6, 8, 10, 12, 13. Well, it compiled. Let's see if it actually works. Build parsed hello world. Well, that did not exactly work, which is unfortunate. Now the question is, how do you debug that? Well, let's look at assembly, shall we? We haven't done that in a while, so let's look what happens. Step into, and let's look at this stuff. So this is our stack. Ta-dan, ta-dan, ta-dan. So first of all, I need to look at ECX. This seems actually correct, I think. So if I change to programmer and do minus 11, that's not very interesting. Yeah, so FF is fine. I just need to verify. Well, actually, no, that everything else should be fine. So we get back something. We get back this 5C, which might even be the same for all apps. So I could try to verify that that value is actually correct handle. Now we are getting ready to so this is a necessary move. We move from one to another and then back, but okay, and then back again. Yeah, this is something that definitely should be checked. And we are moving it into a variable. Okay, whatever, that's fine. Then we are loading the address of our string into rex, and then so this is const char star rex. So address is actually correct. We ended up with the right thing. Okay. So this is fine. We're just moving things around. That doesn't matter. Actually, it kind of does. This is the last argument. Let me look at this. To make this smaller, something like this, and like this. We put this in there. Okay, So yeah, this is the 0. We XOR L and then we move it. Okay, so this is actually the last argument. Okay, and RCX is should contain, yeah, okay, so RCX does contain the handle that was returned, so that's fine. RDX contains the address, and that address does contain the right string. So that's okay. Then what is next? Next is R8D. This is what needs to contain the length. I need to check that it's basically 13. Well, it looks to be 13. I think D is indeed 13. Then we clear IL and move it into R9. Then we clear IL, move it into, like, this is quite useless, but it's fine. And this is the last argument, which should also be 0. So I can do RSP plus 20. And I would say that that is S64 star. Sorry. Unsigned long. Well, it is 0, so that is very, very interesting. So write file, return to us -1. That probably means it was really unhappy. Well, let's open Firefox and look at MSDN write file function. Remarks. Maybe I should provide it before we go any further. I want to actually verify that passing 0 here will work. So I will do this stuff here. I will say write file. First we'll get std output, get std handle of std output handle, get full. So now it's 6 and 0, 0. So let's verify that that works, because I'm not certain it does. Okay, so it actually does work. And just to eliminate maximum weird stuff, I will get rid of all the variables now and do this directly. So like this. Okay, it still does not, is not happy. And what do you return? You return bool. I guess -1 is truthy. Return value. If function. So it actually says it was successful. This is very, very confusing. And number of bytes to write. So this is this thing, D word, LPG word. Everything looks fine to me. Well, I guess we need to try that again. Debug, step into disassembly. And maybe what I can do is to go here and try to see what is the difference in arguments between what we created and what happened here. Where is this stuff? Yeah. Okay. So let's run to here. Now I will also switch into disassembly. And we'll start comparing. So this is not interesting. This value is okay, so value are actually the same. Rux is the same one, so or not. So we actually got a different value, but last time we did get 5C. I think it might be just because we have more processes that are running. I'm not sure. For now, let's say that that's okay. And then we move. So basically, now I will skip over everything before calling. And here, sort of the same way. And we can look at our registers. So we're interested in RCX. RCX contains the getStd handle, so that's fine. Then we have RDX. RDX contains pointer to the write file function. We can't verify that because every process has different address space. So, I mean, we don't know. Actually, speaking of that, I'm stupid. Okay, that was very dumb error. But it's good that I started talking about addresses because I just imported the wrong function. And because like the original parameter was fine, it was pretty happy to do whatever it wanted to do. Maybe I need a better syntax to not repeat this name twice, so I don't have mistake. I don't know. Let's try that again. Oh, yes. Okay. So actually, everything was great. Everything was fine. The only problem was you need to import the right things if you want the program to work, which is, you know, very, very true. Well, that is very nice. I think I'm very happy with the state we are in. Now we can have a Hello World program that is mostly okay. There is a bunch of work to be done on pointers still, but for now, That's it. Thank you very much if you made it this far. This was a bit of a lengthy episode, and hopefully I see you next time.